Hi, folks. Sorry we're running a few minutes late, having some PDF, fun, as always. Wonderful. I see we've got a bunch of people here. Some of you are familiar with this API, so that is great. I'm just going to pull up my questions so I can see any questions that come in. First, can somebody tell me, maybe in the chat, that they can hear me, so I know that you guys have me? And that we can see my screen. There. Oh, nice. Excellent. Thank you for letting me know that you can hear me, Jamie. Wonderful. All right, so I'm Karen Rubin. I know many of you from looking at the list, and we have chatted before. I am super excited to show off the Pipeline API. Obviously, you've seen me in the forums a lot the last couple of days talking about this and sharing it. And today I plan to just cover essentially how we got where we are, and then run through two examples talking through them and answer any questions that come up. So feel free to throw out your questions and let me know it's there. So I will, let me see. It seems like most people can hear me. So Nicola, I see that you can't. I'm not sure what's going on, but I'd check your speakers because most people can hear me at this point. All right, so we're going to get started and chat about the Pipeline API, which is, again, like I said, something I'm really excited about. So the first thing that, just a reminder, because this is where this all came from, what we're trying to do here is build the best platform for the production of uncorrelated return streams. And so as we've been started to push the message of the fund that we're trying to build and the types of algorithms we need out of it, you guys were really great at giving the feedback that it was just very challenging to build stuff that had large enough universes. It was really hard to select the universes, and as we talked about, we want algorithms that, this is a type of algorithm that we think would be really good, starts with the entire universes of stocks, all the 8,000 US equities on any given day, filter down to some subset like the Russell 2000, rank that subset based on some factors, long the top X%, short the bottom X%, and rebalance on some scheduled frequency. And the community just in large was telling us over and over and over again that they wanted this kind of functionality. I need to be able to rank the universe on this factor. I need to be able to create a custom fundamentals factor. We heard it constantly all the time, and we're listening, and that's where this pipeline came from. As you know, the limitations previously were things like our universe size was limited to 200 and then 500 securities. Before trading starts, didn't include the pricing data, so you could do some universe selection based on fundamental data, but nothing that include both data sets. And you had to fit the whole model into the 50 or 60-second bar, depending on doing it in handle data or before trading starts. So all of these things made this just a really challenging problem for you, our community, to create the types of algorithms you wanted to create for the fund and we want you to create. And then enter the pipeline. And so this, as we've been talking about in the community, it lets you do all of these things. So you start in any pipeline with the entire universe of securities known on that day in your backtest. 8,000 plus securities generally, and you can create factors and filters in order to massage that data, massage that universe down to what you're really interested in. So you can calculate factors using pricing, volume, and fundamentals data. You have the full history for all of this data, and you can combine these data sources in any way you want. You've also seen an announcement recently about the Quantopian store, and in a very short period of time, we'll be giving you the ability to include all of the Quantopian store data sets within the pipeline as well, so you'll have access to even more, which will be just a great way to pull together all this data and not have to spend a lot of time doing the data munging on your own. And then you can use any of that data that you add into your pipeline to narrow down your universe and your algorithm to make decisions. And so we're going to walk through a couple of examples, just showing this information and talking about how you use the pipeline in order to do these things, and we'll go from there. So any questions before I just dive right into that stuff? It's funny, I just realized I told Nicola verbally to work on her audio, but she can't hear me, so that didn't work. Give me a second to message her. All right. Doesn't look like I have any questions on the intro, so I'm going to dive into the first example. The first example is super simple. I want to invest in the top 500 securities ranked by revenue and rebalance this monthly. And so I'm going to just switch over to my example here, and I will make the, I'm not on a Mac, there we go, that works. Make the font a little bit bigger so you all can see that pretty well. Here we go. So one of the big things you'll notice about this API that's new in the Quantopian system is that it does require you to import the different elements that you're using as well as the data. This is a sort of a change in the strategy of the API as it's getting larger. Needing to be able to import the various things and understand what you're working with becomes more important. And so you'll start to see this in a lot of the work that we're doing. And so here we have our import statements to pull in the different elements of the pipeline as well as the different pricing data that we're going to use. And so for this algorithm, what I want to do is basically look at the entire universe of securities, and then I want to rank them from top to bottom by the revenue. And then I'm going to take the top 500 and invest in those. And I'm going to look at that every month to rebalance it. I do my standard, I set slippage, I set commission, I set my leverage to be 1, and then we get into the pipeline work. And so the first thing you have to do is you have to create your pipeline. And each pipeline is a standalone item. This is going to allow us to do a couple things in the future. One, this will make it really easy to use the pipeline API in research in a way that maps and looks the same as how you're using it in the IDE, so that code can be copied from one to the other really simply. And two, we do envision a world in the future where you can do multiple pipelines in an algorithm. This was some feedback we got from our early alpha users that you might want to create your long and short lists using different data and create these pipelines separately. And so we started the work of creating the API in such a way that that will be possible in the future. You also then need to attach the pipeline and basically declare that we're using this pipeline in this algorithm. And when you do that, you get a chance to name it. And that is, again, in the interest of someday being able to do multiple pipelines and having multiple pipelines that you're referencing. So I throw those two things in right up top. One of them declares our pipeline, the other attaches it so that we know that this is what we're using for this algorithm. Now, one of the really important things to understand about this entire API is it's declarative. So there's no data in these being passed in these actual lines of code that I'm writing here. I'm declaring the information that I want so that when my pipeline is run and is computed, we can just go and take a look at it. And we do work internally in order to map it in the best way so that it can be performant and work really fast. And the way that it's all math of NumPy arrays. And so we're basically looking at all of the data and pulling them together so that we can do this in a performant way and calculate it in mass, essentially, as opposed to looping over it one stock at a time. That's what allows us to get this done in a faster way. So the first thing I'm going to do is get the latest revenue value. And right here what I'm doing is I identify that I want the Morningstar income statement total revenue. That's just the fundamentals data field that we've got. And I'm going to do .latest, which is just a quick way to say I want essentially yesterday's close price. I'm sorry, yesterday's revenue. And so this will give me the revenue as of yesterday that our system knew it. Now, this entire API works on daily level data. And so the way to think about it is you're taking a kind of broader based data, less fine-tuned data, and you're using that to narrow things down, and then you can do use the minutely pricing information in before trading starts or in handle data to make other decisions. First, I set up revenue as a element that has this revenue of the last day for every security within the universe, and I add that to my pipeline. The output of my pipeline is going to be a data frame where the index is every security in my pipeline and the columns are anything I add to that pipeline. I can add factors like this, which is a numerical value, or I can add filters, which is a Boolean value. If I add a filter to my pipeline, it's going to show up just as true false within the pipeline so that I can choose to add that and see the results and then make decisions in before trading starts. We're then going to use rank to rank all the companies by revenue. And so this here takes that revenue factor that I've defined up above, uses .rank, which is a function that will basically say, take everything here, rank it from, it does bottom to top, so I've set ascending to equal false. And it gives me and then I add that as well to my pipeline. So it actually is going to add a column called rev rank that tells me what the rank of the revenue is. Now, one of the interesting things that ranking has is the ability to add a mask, and I'll show that in the next example, but you can basically say, I want to rank everything within this universe by masking out certain securities that do not pass a filter, and that allows you to get more granular in which securities you actually care to rank. The other thing that I need to do in this algorithm is make sure that I'm only working with the primary share classes. And so I again get some data from my fundamentals. The Morningstar share class is primary shares, which is a Boolean value, and I'm going to get the latest. And I set that to equal share class, or share class to equal that. And then I'm going to set a screen. And what the screen does is allow me to filter out securities that don't pass my screens. And so the difference between pipe.add, in pipe.add, you're adding an actual column to the output of your pipeline. You can add a filter, and then you'll have a column that says true, false. When you set a screen, you're actually telling the pipeline, don't pass through any securities that do not pass my screen. And so that actually removes those securities from getting passed through in the pipeline. So here we set screen, and what I'm doing is I only want the companies where the revenue is greater than 1, so I want positive revenues, and I also want to take a look at anything where the share class is equal to 1, because primary share class is again a Boolean, so 1 means true. So I want everything with revenue greater than 1 and the share class of primary shares, so I know I'm only looking at the share class. There are some questions in the community recently about set screen, and you can do ands or ors within set screen. If I wanted to make this an or, I just throw a pipe in here, and that would give me an or. In this particular case, I'm going to do and. Scotty wrote a great example of explaining why this is the way it is in Python, and so you can use that for reference if you need it. In this particular example, I'm also then going to schedule my function, and I'm scheduling this using same function we've always had, schedule function, to run at the start of every month, 30 minutes after the market opens, and I'm calling a rebalance function here. And so what I'm going to do, as we can see, is get the revenue, rank the revenue, remove anything that's not a primary share, and then every month I will do that and take the top 500 and invest in them. So scrolling down, before trading start is where I recommend that you run your pipeline. At this point in initialize, nothing has been run. Now remember, initialize runs at the beginning of your algorithm. It runs the first time you run it, and all it does here is set up and declare the information that I'm going to be pulling out of my pipeline. The pipeline actually gets calculated the first time when I call pipeline output. So the first day of my back test and before trading starts, when I call pipeline output, what the pipeline API does is it looks at everything you've declared, figures out how to calculate it most performantly, and it goes and does that calculation for every security in your universe for the first year. And so it batches these in year-long chunks to get all of the information for you, and then pass it to you on each day within your back test to ensure that you're getting the right information on any given day and that there isn't look-ahead bias. And so if we go back up to where I declared my pipeline, I called it top 500. Down here in when I call pipeline output, I again say that's the one that I want, the top 500, and I'm going to store that in a context variable. So this context variable, context set output, is going to give me everything that passed my screen, so significantly more than 500 securities. And it's going to give me the revenue and the revenue rank that we defined, and then I can do with it whatever I want. So I do a couple things here to make this easier. The first thing, or make it work for me, the first thing I do is I fill any NAs with 0. With some of the fundamentals data, we can have information that's nan, and I want to just make those 0 so I have a value in there that I can work with. I'm going to do some work within our universe. As I was working on this, I realized we have securities that are the ticker symbol _WI, which is a when issued security. And for the purpose of this algorithm, I don't want those included. So I did a little bit of work here within pandas in order to just remove everything that has _WI after the ticker symbol. And so there's a little bit of work to take the SIDs, map them to symbols, take the symbols, get them into strings, and then remove the ones with the WIs on them. The next thing that I do is I narrow down the securities to only the top 500. And so again, here I made my variable top 500 is equal to my output where everything's filled with zeros. I then take top 500, I sort it by that revenue rank that I added into my pipeline. I set ascending equals to true, and I take the first 500. So I will take the 500 largest companies by revenue. I then use that to update my universe. And again, we're working here with a data frame where the index is the security, the SID, security identifier for anything in my universe. And so I want to take it to that data frame .index and make that how I set my, my universe. And so what I've been able to do here is essentially analyze the entire universe of 8,000 securities, narrow it down and rank it so that I only update my universe with the 500 I'm interested in, but I was able to do the analysis across everything. I then go into the rest of my algorithm. All handed data does is set the leverage or record the leverage, and then in rebalance, I am rebalancing my algorithm, taking the universe once a month, essentially, and then ordering it and readjusting my ownership. So I'm going to go ahead and build that so that we can take a look at the results over here. And you'll see when we start to kick this off, it goes and it has to gather all of the data and then do the computations for my pipeline. Especially when you're using fundamentals, you'll notice as your backtest runs that as it comes to the year mark for every given year, things slow down a bit. And that's because it's going and calculating the next year. Right now, each fundamentals data element that you pull takes about 15 or 20 seconds to get. And so within before trading start today, you've got 5 minutes to work with. And so there are limits that you'll run out of time if you pull in too many fundamentals items. We have one speed up that we're doing shortly that will head out the next day or two to help with the fundamentals, the slowness of the fundamentals, and it's something that we're continuing to work on. I will tell you that memory and timeouts is something we're focused on with this API and making it something that can get done within a reasonable amount of time. And if you're trying to work with an algorithm and you are running into timeout issues, you should definitely reach out and share with us what you can so that we can help figure out how to do it in a performant way and get the information into our system so that we can continue to improve it. This continues to run, and what we're going to see over here, actually, I'm sorry, I removed this. I think in my example, I removed everything where I print information. So let me just cancel that really quick. And I'm going to add in, I need to print log.info. I'm just going to log the output from my pipeline so that we can see it. That's what I was expecting to show there. Let's try that again. Then I spelled that wrong, so this is what I get for programming on the fly. You guys are my first demo of this algorithm, so please bear with me. So what we should see while this kicks off is the output of that data frame, because I want to show you what it looks like with the index and the columns from your pipeline. And so there's a lot that you can do here, and there's a lot that we plan to do moving forward in order to be able to continue to help people calculate interesting pipelines and get the data into before trading starts and handle data so that you can make the decisions that you're interested in. Give this a minute to run. Any questions, feel free to throw them in on what I've displayed thus far. I can definitely take them and answer them as we're going. This is taking longer than I would have expected. Again, yay for live demos. There we go. All right. So here you can see I have all the companies ranked by their revenue. No, these aren't ranked. I didn't rank them yet. So these are companies coming in alphabetically. You can see my data frame here. I've got the first column, the index is the security objects. I'm then looking at the revenue rank and the actual revenue being shared with me. So that's what the data frame will look like, and then you can use pandas and NumPy to do whatever you want. I think one of the important things to remember, and that we'll look at in the second example, is that these factors can be combined to create new factors and then used together. And so we'll take a look at that now. I'm first going to show you my example. Unfortunately, it's a PDF, so I'm not going to have my beautiful builds, but bear with me. So example 2, this is the example that I've shared in the community. It came from one of our community members, Bo Dong. It is a great example. I was really excited by it, and it's been a guidepost for me because just after we finished designing the first version of this API, he shared a request in the community in order to build this. And there's a bunch of back and forth trying to help him, but it was very challenging in the previous system, and now it's very simple. And so he wanted essentially 2 factors, a liquidity factor, which was trading volume over shares outstanding, and then some kind of a momentum factor that was the price of the current day over the price 60 days ago. And then he wanted to rank the Russell 2000 stocks every month long the top 5%, short the bottom. So what essentially, Just sat down with me to help me understand exactly how to build this, because I've never built an algorithm like this. And the thing she told me in terms of combining the 2 factors, and what we worked towards was creating a combo rank of these 2 factors. So what my algorithm is trying to do is get my liquidity factor in its raw form and then rank all of the companies by that. Then get the momentum factor in its raw form and then rank all of the companies by that. And then do basically an average of those 2 ranks, the liquidity rank and the momentum rank, and then rank that. And so I have gone about implementing this here, and we can take a look at it. One of the nice things about this algorithm is it uses equity data, fundamentals data, it combines the factors, it does a whole bunch of ranking, and it uses custom factors. So we'll dive right in here. Again, we import everything, and then the first thing we do is create 2 custom. Oh, hey, so if you want to ask questions, you actually have to type them in the question box. I don't think we can ask audio questions here, but let's see if I can change that since we don't have so many people. No, I think because we're in a webinar, I have to have you type them in now. So sorry about that. But feel free, type away, I am watching. So here we go. What is to be expected for the performance in a min timeframe backtest? So I'm not, this is from Michael Jackson. It's nice. And so in any case, expected performance for a minimum timeframe backtest, the performance on fundamentals is the thing that slows it down, and it's about 15 seconds per field right now. That again should get faster within the next day or 2. Outside of that, the pricing data doesn't really, it obviously takes a little bit of time, but you can basically get as much of the pricing data as you want without any problem. So within the 5 minutes, the belief is that there's a whole lot you can do there. We are still waiting to see what you, our community do that run into problems with, so that we can continue to improve things upon that. I know there was an example yesterday that Scotty shared. Scotty, when I referenced him, he's the engineer that's responsible for all of this. That was looking at doing a Z-score, I think, and he showed how to do it using a custom factor. There are some ways in which he can make these faster by making them built-in factors, and so it's definitely worth sharing the information with us so that we can optimize the system to work even better for you. Yeah, so Michael Sterling is asking, he's curious about the order of operations for adding components to the pipeline. And so adding components to the pipeline, that's a good one. I'm actually going to go back to my Quanto 500 example for this. What's interesting is the order doesn't matter at all. So all of this information that I've added here for the pipeline, you can do in whatever makes the most sense to you, because it essentially is all declarative, and at the point we run the algorithm, the first time that the algorithm goes and calculates your pipeline, when it does the pipeline output down here, it basically goes through this and creates a tree essentially to figure out how it can get this information and combine it for you in the most performant way. So I could do my set screen at the top, I could add my factors all together and declare them as inputs in a separate place. The order of operations does not matter because of the work that we're doing. So you're asking an interesting question about if you'd wanted to do the fix for WI as part of the pipeline, what would the workflow have been for that one? I actually don't know. The reason I did it in the data frame was because that was the way I could figure out how to do it. It's something on my list that I've been meaning to ask Scotty if there is a way to do that as part of the pipeline. I just haven't had time to have him look into it yet, so it's a good question. And when I figure out the way to do that, I will definitely share it with the community. Thank you for the questions. So back to the Bodong example. This one, we first create those two custom factors that I mentioned. The liquidity custom factor, we identify these as classes. And so this is going to be the trading volume and the shares outstanding from the previous day, so the most recent of those two pieces of information. When I declare my class, it's a class of type custom factor. I have the choice of putting and defining the inputs and the window length when I create the custom factor, setting them as defaults. I can also pass them through, and if I pass them through when I call the custom factor, they will override the defaults. In this case, I'm going to declare them. My two inputs are US pricing equity.volume and then the Morningstar valuation shares outstanding. And I'm going to set my window length to 1 because I'm really only interested in this information for yesterday. I then define my compute function, which is where the work is going to be done. And this is the first factor, the liquidity factor. And so there are 4 required elements in the compute factor: self, today, assets, and output. And then I also have to include the inputs that I declared up above. And so that's volume and shares. And those could be called whatever I wanted them to call. It just pulls them from that input statement up here. I have to declare this as output, and essentially you have to remember that what you're doing here is working with NumPy arrays. And so what I essentially do is I say I want the volume from yesterday and the shares from yesterday as well, and I do my math with those two elements. So as this goes and computes it, you're essentially getting a NumPy array of all of the securities with the columns for volume and shares as the inputs, and then it goes through and does the math. So then the second factor is momentum. This one's just based on the close price, but it's the current day over the price 60 days ago. So I set my window length to 60. My compute is self, today, assets, and output. And close is the other input, the new one. My output is the close of yesterday, so close minus 1 over close 60 days ago, which will be the last element in my window, over the close of yesterday, which will be the first. And so I just run through and do the one over the other there. And the last thing I'm going to do is create a custom market cap. We want to get the Russell 2000 essentially, and Russell 2000 is the top 2,000 stocks by market cap. And so I pre-declare my inputs to be the close price and the shares outstanding. This will give me an updated market cap based on the most recent close price. Window length is set equal to 1, and again, close is yesterday's close times shares. Michael, you've got a question about what tools are being used in the background. Does it use Dask for the computation? Don't feel like it has to be your last question. You can ask plenty of questions. Or does it construct a DAG and then compute in the appropriate order? This is actually, Scotty has written in the documentation, there's a whole thing where he explains how it's computing the graph that needs to be done. You should go take a look at that, and then feel free to email us, Karen@Quantopian.com, and we can get into the details of that with him too. And are there plans to open source any parts of the pipeline? There are. It's all open sourced. It's in Zipline. The entire thing is. So any factors that you want to add for the whole community to use, you can go and take a look at it there. So feel free to go look at Zipline, and all of the pipeline is there. All right, back to my example. We've got the market cap, close price, shares outstanding, and we calculate that. Now, in my initialize, I'm doing a lot of work here because remember, I want to get these factors for liquidity and momentum. I want to then rank them. I want to then combine them to create my combo factor, and then I want to rank that. So I attach my pipeline. I call it the ranked 2000. I'm going to add my two factors, my liquidity factor. I'm going to add that to the pipeline, and then my momentum factor, I'm going to add that to the pipeline. So those will be the raw values for those factors. I'm then going to apply my filter for the Russell 2000, and this is where we get into the masking I mentioned before. So I calculate my market cap factor. I can then use top 2000, or market cap.top 2000 will make sure I get just the top 2000 companies by market cap. And I'm going to set that as a screen for my entire calculation, basically saying I'm only interested in the top 2,000 companies by market cap. Then when I rank my factors, I'm going to make my liquidity rank. And when I do that, I'm going to say mask it to the top 2,000. And so what this will do is it'll take everything within the universe. It will take only those that pass that filter of being in the top 2,000 and rank them based on liquidity. I then add that rank as to my pipeline as well. I do the same thing for momentum, and I mask the top 2,000 out, and I get the rank for momentum. And then I, from there, get a combo factor. And again, here you can see the fact that with these factors, you can just do any kind of math, and the result is a new factor. So here I take my liquidity rank, I add it to the momentum rank, I divide by 2 to get the average, and I add that as a combo raw factor to my pipeline as well. I think you might have just lost a little bit of audio there. Hopefully it is back now. But what I was saying is I just do the math between the factors, results in a new factor, and I add that to my pipeline as well. Now, you can choose not to add these all to your pipeline. For the purposes of the demonstration, I'm adding them because it's easier to see. However, if you don't add them all, you can still work with them, and it will work just fine. I then have my rank, I added that, and I do my schedule function. So what we're expecting to see in the resulting output of this pipeline is a whole bunch of information. My liquidity raw, my liquidity rank, my momentum raw, my momentum rank, my combo raw, and my combo rank. Whole bunch of information. I schedule this again to do a monthly rebalance. And before trading start, this is where I call the pipeline output for ranked 2,000. Again, I'm going to do my fill NA of 0, and I'm actually setting a limit right off the top to get the momentum for being greater than 0. And then I narrow that down to the securities that I want. And in this particular case, although my comment here is wrong, I'm getting essentially the top 100 and the bottom 100. The top 100 becomes my long list. The bottom 100 becomes my short list. I add the union of those two lists of their indexes together to update my universe. And then from there, I go about buying both sides of longing the long list, shorting the short list, and rebalancing monthly. And I'm not going to go through all of that code. I will set this algorithm to build so that we can take a look at the output. And what we should see is a long list sorted by the combo rank and a short list sorted by the combo rank. I will say the challenging thing, or what I have found to be one of the more challenging things of building these types of algorithms, is thinking about how you're ranking something in the order of your rank. So by default, rank sorts ascending. So the first element, number 1, will be the smallest. The nth element, the 2,000th element in this particular case, will be the largest. You can pass ascending equals true or ascending equals false into your rank function. So I can do that up here, which I didn't do, but if I wanted to reverse these, I could, and sort them in a different way. But when you're thinking about ranking the various elements and then combining them, it's important to make sure that you're ranking them in the correct corresponding ways, and that then when you're doing the top and bottom in order to make your investments, thinking about how you want that to work. So here is my output. And you can see here, this is actually a great place to understand how the order of what I'm doing in the initialize doesn't actually change the results. And so you can see here what I end up with is the combo rank, the combo raw, the liquidity rank, the liquidity raw, the momentum rank, and then the momentum raw, when in fact I added these in an entirely different order. So just keep that in mind. And then what this is doing is exactly the math that I pointed out, and it's doing it across the entire universe. So we're getting the resulting output is limited to the 2,000 securities because I set the screen to just be the top 2,000. However, I could run this for the full universe of 8,000 if I wanted. Now, you'll see that this algorithm does not perform particularly well, but it is the algorithm that our community member wanted in a much more simple way to create it than before. So these are the 2 examples that I wanted to walk through and talk about with what we're doing here. If you've got any more questions, thank you, Michael, for all your wonderful questions. I appreciate it. I'm happy to answer them and talk about this a little bit more if there's anything. I also have to give a big shout out to our alpha users. I see a few of you on the webinar here. But we got great help from a group of about 12 or 15 alpha users giving us a lot of feedback, which has been wonderful in all of this. So I am happy to help folks with creating pipelines as you are working on them. Feel free to share it. What I've been working on is going through the community. It was amazing as we were building this because so many people, as I was building it, every single day there was another person in the community asking for help doing something similar to this. And so I've been able to save up a backlog of people trying to do stuff, and I am now working to implement those using the pipeline to use as examples. So if you've got something that you want some help on, feel free to reach out. Again, I'm Karen at Quantopian.com. Always you can reach me through the community, and I'd be happy to walk through this. In terms of things that we're adding, we are actively working on a variety of things. One is adding this to research. I love research. I 100% believe that the best way you guys are going to be able to build great factors is by working on them in research and exploring them. We didn't want to hold this back until we had it in research, but that is on the roadmap in the short term. Another one is getting it working in paper trading, so we can start getting algorithms using the pipeline into the contest. And so that's a high priority. And then the last thing is we also, and we talked about this when we first presented this algorithm, is the idea of classifiers. And the classifiers are the ability, it's basically where a factor is a numerical object, a filter is a Boolean object, a classifier is membership in a group. So you can see a world where you really want to create algorithms where you have your factors, but you want to rank them based on what sector they're in, because different sectors are going to have, you know, different PE ratios or different liquidity numbers that are normal. And so you'll want to be able to apply a classifier to your pipeline. That's also definitely in the works. And Simon just brought up a very good point that we want to talk about the subtleties of the API with respect to rolling forward split and dividend adjustments. Yeah, so the pricing in the pipeline API is as of pricing, which means that you get the price as of, I'm sorry, I struggle to explain this sometimes, so we'll keep working on it, but you have dividends and split adjustments incorporated in your historical windows as you pull those in, and then the price today is what the price you would have gotten on that date in history. And so this is one of the first times that we've got dividend adjustments taken into account in the pricing as well. You will see those also pulled into the back tester, into the pricing data there in the next couple of weeks. So know that there are some distinctions there. There is also a slight, what this has done by pulling the dividend stuff out is showed some bugs in our data, and we are working on resolving an issue where dividends are getting paid in foreign currencies. And so this does result in some like oddities right now because of that, but we're working on that fix coming through. So you'll notice in all of my examples, I do something where I look for things that are greater than 0 or greater than 1. I filter out penny stocks, and that's in part to deal with the dividend adjustment errors that are still there. So know that those changes are reflected in this pricing information as well. Excellent. Well, if there are not any other questions, I appreciate you all here. Thank you very much for the feedback. Thank you for the help in the communities. And please continue to give us your thoughts and help us improve this pipeline. We're really excited about what it's going to open up in terms of algorithms from the community for the competition and for the fund. And so we definitely want your feedback and your thoughts on it. Thank you very much.